too. This is kind of a fun one. Oh, hi. I was just going through my box of comics that I've been collecting, and I must say that I do not like sharing my box of comics. And that reminds me of a story where we have two people who also do not want to share, but because of an interrupted game, I think they might have to. Let's check it out for ourselves and see if we can figure out the scenario and figure out what is fair. Okay, Logan and Ashley are given a box of 200 comic books. Now, rather than share the comic books, they decide to play a game with the rules shown right here to determine who gets all of them. Now, check out the rules. One of them repeatedly tosses a coin, and it's a fair coin, so it's just as likely heads or tails. When the coin lands heads up, Logan gets a point. When the coin lands tails up, Ashley gets a point. The first one to reach 25 points wins the game and gets all 200 comic books. Okay, but the plot thickens. As Logan and Ashley are playing the game, they're interrupted and are unable to continue. How should the 200 comic books be divided between them, given that the game was interrupted at the described moment? And the described moment in this case is when they were interrupted, Logan has 21 points and Ashley has 24 points. Okay, now let's just think about this for a second. First of all, realize that if they were to keep playing, that is, keep flipping their coin, then in fact, they'd only have to play at most 4 more times. And that would be if in fact, we keep landing on heads up, heads up, heads up, heads up, and then in fact, we do that 4 more times, then Logan would win. But Ashley already has 24 points rather, which means that all she has to do is land tails up once, and the game is over. So for Logan, he has to actually flip it 4 times and get always heads up, and Ashley, just 1 flip, tails up, and she wins. So at most, in either case, at most, 4 coin tosses are going to be required to win the game. That's it, because within 4 coin tosses, there will definitely be a winner. Either it'll be Logan because they were all heads up, or at some point along the way, there's going to be a tails up, and then the game is over because then Ashley hits 5 points before Logan. Okay, so let's actually just make an ordered list of all the possible equally likely outcomes, and using H for heads and T for tails, we get if in fact we look at 4 tosses of a coin. So we start with, of course, heads, 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 and then we end with tails, 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 and so forth. So here we go. I'm going to make now a little summary of what we have. So we know that Logan only wins when 4 heads come up before a tail. So now let's make a list of all possible outcomes. Now there are, in fact, 5 outcomes, but they're not equally likely. 0 tails and 4 heads, that's when Logan wins. 1 tail and 3 heads, 2 tails and 2 heads, 3 tails and 1 head, 4 tails and 0 heads. So we can actually now fill in all the possible equally likely outcomes. So for example, for the 4 heads, that's kind of easy, right? It's just heads, 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 heads. But see, with 1 tail and 3 heads, there are a lot of equally likely ways that can happen. First of all, we could have tail, heads, heads, heads. But there's another way that's different. We could have first hit heads, then get tails, then see heads, heads. We could also see heads, heads, and then tail, and then heads. Finally, we could have 3 heads in a row, and then finally land tails up. So in fact, there are 4 equally likely scenarios. So just because we see, 1 tails up, 3 heads up, that doesn't mean that the likelihood of that is the same as anything else. We have to write down all the equally likely possibilities where that heads up, where that tails up could be. It could have been the first, the second roll, the third roll, or the 4th roll. Even more complicated if we have 2 tails up and 2 heads up. There are lots of ways of doing that. Let me just show you all of them. I've worked this out in advance. And you can see, we can either have tails, tails, heads, heads, tails, heads, tails, heads. We could have tails, heads, heads, tails. And those are the only possibilities with having tails up first. So now let's consider heads up first. If you have heads up first, then you could have tails, tails, heads. Then you could have heads, tails, heads, tails. Or you could have heads, heads, tails, tails. And now I've got all possible ways of getting two heads up, two tails up, two heads up, and these are all the equally likely ways. And then similarly down the road, if you have three tails, that's the same as three heads, but just switching all the labels. And then there's only one way of getting four tails and zero heads up, and that is tails, tails, tails. Now, let's circle all the outcomes where, in fact, Logan wins. Well, remember, Logan wins. He has to get, in fact, four heads up in a row. So Logan's going to win only in this scenario out of all these equally likely scenarios. So how many equally likely outcomes are there? Well, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 equally likely outcomes, and only one of them is going to yield success for Logan. And so what that means is that there are 16 equally likely possible outcomes. Logan wins one of them, and then Ashley wins all 15 others, because that means that she will, in fact, have one tails up before he gets all four of his heads up. So otherwise, she wins, and this is he wins. So what we see here is that the probability of Logan winning is 1/16, while the probability that Ashley wins is 15/16. It's much more likely that Ashley's going to win this game than Logan. So now, how are we going to distribute the comic books? Well, maybe what we should do is we should distribute the comic books and give them that fraction of the 200. So give Logan 1/16 of the 200 comic books, and give Ashley 15/16 of the 200 comic books. And we figure that out. Turns out that 1/16 would be, in fact, let me put this way over here. 1/16 of 200 would be 12 and a half comic books. 15/16 would actually be 187 and a half comic books. So in some sense, this is a way of actually distributing in a fair way, given that it's far more likely that Ashley's going to win. She gets almost all of them, but there's a small chance that actually Logan could have won, in which case we'll give him a little bit. Now, of course, you see there's a half a comic book. These are actual, whole things. So what do we do? Are we going to really rip a comic book in half? Well, I don't think so. And so rather than split a comic book in half, in fact, they might just flip a coin to decide and let Ashley, have it if she's, let the coin decide, and let Ashley have it since she's, or you could let Ashley have it since she, in fact, was more likely to win. Anyway, some way of figuring it out. And so the summary, since the probability of Logan winning is 1/16, he should get 16th of the comics. Otherwise, Ashley, her likelihood of winning is 15/16, so maybe she should get 15/16 of the comics, and that's where it is. Of course, I do have a little question about this. I always have a question, don't I? And that is, if they're actually thinking about actually flipping one coin to see who would decide who gets it, then why couldn't they just flip the coin 4 more times at most and figure out who gets all of them? So here's a way where, in fact, they're each going to get some, but in fact, if they were to finish the game, which wouldn't take that much longer after they got interrupted, in fact, one person could have taken it all. Well, the idea of not sharing might not sound like very friendly behavior, but if everyone agrees to that, then in fact, you can go right through and play on. If in fact you're interrupted, then you could use probabilities to figure out one possible way of being fair. Or even better, don't get interrupted. Here's hoping that all of your mathematics happens with great joy and no interruptions, and I'll see you soon.